Today's learning target is I can add and subtract unlike fractions. When I add or subtract fractions with unlike denominators like I have here, my goal is to change these fractions into equivalent fractions so that they have the same denominator. So to do that, I look at each of the denominators and I think, what is something I can multiply each of these by where the product would be the same for each of these. So mentally, I look at this and I say, I know that 5 times 3 gives me 15. And I know I can multiply 3 by 5 in order to get 15. So if I were to do that, each of the denominators would be 15. Now I want to keep each of these fractions equivalent or the same. So if I'm going to multiply the denominator by 3, I have to do the same to the numerator. Okay, and in the other fraction here, I need to multiply that by 5 because I multiplied the denominator by 5. And now that gives me my new fractions. So I'm looking at 9/15 here plus 5/15 here. Notice how I'm showing my work here. Okay, I want you to make sure you're doing the same thing. And when I add that, I'm going to get 14/15. If I'm adding two unlike fractions, like I have here, and one is negative and one's positive, I still need to get my denominators the same here. So I need to find a common multiple. Now when I use the term multiple, a multiple is a number I get when I count by a specific number. Like the multiples of 6 would be 6, 12, 18. The multiples of 8 would be 8, 16, 24. Now sometimes when people are trying to find a common multiple, they'll just take and they'll multiply these two together. Okay, and so we could do that, and that would give us 48. So each of these numbers I can count by to get to 48, but that's going to make more work for us. Instead, I want to do some mental math, and I just think my multiples of 6 are 6, 12, 18, 24. I look at 8 and I know I can get to 24 by counting by 8s. So I'm going to use 24 as my common denominator. So now I multiplied 6 by 4 to get a denominator of 24, so I have to do the same thing to the numerator, and the same thing over here, except I multiplied the denominator by 3, so I multiply by 3 there. And now that leaves me over here with negative 20, don't forget the negative sign, plus 3 over 24. So my denominators are the same, so I'm going to get 24, and now I get minus 20 plus 3, which would give me negative 17 over 24. And 17 is a prime number. That means only 1 and 17 go into that. So I know that this is in simplest form because I know 17 does not go into 24. In this problem here, we're going to be adding a fraction with a mixed number here. And I can see that they're both negatives. Okay, so I'm going to be putting this negative 3/10 together with this negative 5 3/4. Now to do this, the first thing I want to do is I want to add the fraction parts of this. We'll worry about the whole number later. So I've got negative 3/10 here plus, and this is going to be negative 3/4, right? Because this entire fraction is negative 5 3/4. So it's actually negative 3/4. So I'm going to write that down here, negative 3/10 plus negative 3/4. Mentally, I was able to figure a common denominator of 20. So when I rewrite this fraction, it becomes 2 times negative 3 is negative 6 over 20, plus, this would be negative 15 over 20. Now my denominators stay the same. We're at 20 here. And my numerator, I have negative 6 plus negative 15 becomes negative 21. Now I want to get this as a mixed number. And again, using mental math, if I do 21 divided by 20, okay, I'm going to get 1, and I know there's going to be a remainder of 1. So I know this is a mixed number is negative 1 and 1/20. Now I want to take that, and I want to add it together with this negative 5 here. So now I'm looking at negative 5 plus a negative 1 and 1/20. So now I just add the whole numbers. Negative 5 plus a negative 1 gives me negative 6. Oops, I just realized I didn't put a 0 in there for 20th. And my fraction is 1/20. So I have negative 6 and 1/20. So in this problem here where I have two mixed numbers, okay, the first thing I can do is I'm just going to add my mixed numbers. So I've got 40 plus 19 gives me 59. And now I'm looking at 1/8 plus 3/4, right? And we know how to do that. We're going to get this to the common denominator. So if I change this fraction to 6/8, okay, it's an equivalent fraction. It's the same as 3/4. And now I just add my 1/8 plus 6/8, which gives me 7/8, and I had 59 wholes. All right, this problem here is going to require us to do some regrouping, so let's take a look at how we would solve this one. So we're going to start, and we want to get our denominators the same. Okay, so just doing some mental math, I know if I times this by 3 and this by 5, I can get denominators of 15 for both those. So I'm going to rewrite this as 9 and 9/15 minus 7 and 10/15. Now my denominators are the same, so I can take a look here and I can see I'm going to take 10/15 away from 9/15, but I know that'll give me a negative number. So I'm going to do some regrouping here. So I have 9 wholes here. I want to take one of those wholes and I want to add it in with this 9/15. Now the reason I do that is I want to be able to take 10/15 away from some number that won't give me a negative number. So over here I've done the one whole plus this 9/15, okay, and I'm going to change one whole to 15/15. That's the same as one whole plus 9/15 would give me 24/15. So I can rewrite 9 and 9/15 as 8 and 24/15. Okay, because what I've done is I've borrowed 1 here, so I had 8, and then I added 15/15 to this. And now I take away 7 and 10/15, and now I've got a number that I can subtract pretty easily. So I'll do the fraction first. 24/15 minus 10/15 would give me 14/15, and 8 minus 7 gives me 1, so my final answer is 1 and 14/15.